Hello everyone. Today we are going to do the experiment specific heat of a solid by the method of mixers. So first of all, what do you mean by specific heat? It is defined as the amount of heat required to raise the temperature of 1 gram or unit mass of a substance by 1 degree centigrade. So here today we are taking our solid lead shots. That means what? We are determining the specific heat of lead. Okay. So, on what principle we are going to do? This works on the principle of method of mixers. So, what is meant by method of mixers? When you mix a hot body with a cold body, what happens? The hotter body becomes, the hot body becomes cooler and the cooler one becomes hotter. So they come to some resultant temperature. So if no heat is, the principle of method of mixers is this. If no heat is given to the surroundings, okay, just put a comma there. Heat lost by the hot body is equal to heat gained by the cold body. So this we are going to determine with the help of this called as calorimeter. So what calorimeter? This is made up of copper. So this is called stirrer. To stir the contents of the calorimeter, copper calorimeter. And this is just a wooden box stuffed with a bad conductor. Because we said that no heat should be given to the surrounding. Suppose I keep a hot body here, open, just open. Then after some time, it becomes cool. That means what happened? Where the heat has gone? The heat has gone to the surroundings. So in this particular experiment, I don't want the heat to be shared by the surroundings. I want the heat, when I transfer a hot body, to be gained only by the calorimeter and the water which I am taking. So actually, this is briefly what we are going to do. Okay. So, first you have to determine the mass of this empty calorimeter with the help of balance. Now, this year, the physical balance experiment is deleted for you. So, using physical balance, you can find the mass very accurately to 0.01, okay, milligram, 0.01 accuracy. So here you can just do with the help of a rough balance. Okay, so use a rough balance and determine the mass of empty calorimeter plus stirrer that you are taking it as W1. Then we will take little amount of water in this. So I'm adding water in the calorimeter. Little amount of water in the calorimeter, and again take its mass with the help of rough balance only. So again, no, don't keep it now. Again with the help of balance, rough balance, you take its mass, whose value is W2. So after taking W1 and W2, you take a thermometer. And you just note down the initial temperature of calorimeter and water. You can keep inside, or if you keep outside also, it will be the same thing, because you have not yet heated this particular one. You have not yet heated. So you can just note down it is how much today. It will be just between 25, 27 like that. It is showing 25. That is T1. T1 is calorimeter plus water temperature. After noting down W1, W2, T1 degree centigrade, we have to heat. Is it necessary that you should heat only lead shots? No. You can take any solid. Suppose you want to determine the specific heat of gold. You take gold in the form of small pieces. If you want to determine the specific heat of iron, take iron in the form of small pieces, which are called as iron filings. So today we want to determine the specific heat of lead. That's why we are taking lead in the form of small spheres, which are called lead shots. Okay. So how much to take and all, it is our wish. Now I am taking, first of all, let me explain this steam heater. This steam heater, it will be like this. You will be pouring water from this. It is a two-layered vessel. Now from the center, see here you have an opening. Now this is not uniform front and back. The projected part, the protruded part, you just keep it like this. Now after keeping this, I filled it with water. Okay, I filled it with water. Now you just keep lead shots. Are they coming out? No. They are not coming out. So they are there. They're there. So now I'm going to keep it on a stove. I'm heating it. Okay. So, and when I'm heating, I have to put one thermometer inside it. I know down to what temperature it comes, 97, 98, like that. Its temperature rises. So I'll heat it to that extent. When it comes to 98, 99, like that, okay, I feel it's ready for transfer. This is what solid lead heated to a very high temperature. Now when I want to transfer the lead shots into the calorimeter. Now what is there in the calorimeter? Water is there. Okay. So I have to keep this calorimeter in the wooden box stuffed with bad conductor. Okay. So that the heat absolutely will not go to the surroundings. So now I have to transfer. You come there. So just hold it here. What I'll do is, I have noted down the temperature of hot solid. So the hot solid is transferred where? Into the calorimeter. Immediately you must cover. Time gap should not be there. Immediately you transfer. You take another thermometer, not the hot one. Another thermometer. Insert and note down the resultant temperature. Now what are there in this? Lead shots are there. Water is there. Calorimeter is there. Okay. Now again with the help of rough balance, you note down the temperature of the resultant temperature, which is what we have written here. Temperature here, this side I have written resultant temperature T3. So you have noted down 3 masses, 3 temperatures. I repeat, number 1, mass of empty calorimeter W1. Mass of calorimeter plus water W2. Okay. Mass of calorimeter plus water plus lead shots W2. W3. Okay. Then 3 temperatures. What are the 3 temperatures? I'll tell you. Number 1, the initial temperature of calorimeter and water. T2. T2 is the temperature of the hot solid. And T3 is the resultant temperature after you transfer the lead shots into the calorimeter. Now, this formula, which is written on board, is arrived. There is a big derivation for this actually. Okay. What is the principle used in this? Heat lost by the hot body is equal to heat gained by the cold body. Now, what are the things you have to think and tell me? Which body has given heat? Which body has taken heat? Heat is given only by lead shots. Heat is taken by water, not only water, calorimeter also. Okay. So total heat gained by calorimeter and water should be equal to heat lost by lead shots. That is, we are equating, and after simplification, you arrive at this formula. Now, let us say in this particular one, what is W1? You know, let us see whether you know all these or not. W1 is mass of empty calorimeter. And what is S1? I have written S1 is specification of calorimeter. This calorimeter, now you can take, because you have taken the mass also. This calorimeter is made up of copper. You have to understand one point here. The specific heat is something to do with the material of it. If you take 100 lead shots, its value will be more. If you take 10 lead shots, its value will be less. It is not like that, because whether you take 100 lead shots or 1000 lead shots, you are going to calculate specific heat. Definition is the amount of heat required by unit mass of the substance to raise its temperature by 1 degree centigrade. So how do you rise the temperature of a substance?
By heating.
By heating it. By heating it. Okay? Correct. Good. So that amount of heat required by unit mass of the substance to raise its temperature by 1 degree, you call it as a specific heat. So why I'm asking this is, you should understand this. This is something to do with the material. Gold has some specific heat value. Copper has some value. Iron has some value. Like that, this specific heat is characteristic of the material of the substance, but not the amount of the given substance. Okay? So that's why here I have written specific heat of calorimeter. Actually, I should write specific heat of the material of the calorimeter. Since the calorimeter is made up of copper, I have written its value 0.09, which is approximately equal to 0.1. And what is its unit? Calories per gram per degree centigrade. Our calories gram to the power of -1, degree centigrade to the power of -1. Okay. Next, specific, what is W2? Mass of calorimeter plus water. S1 I told you, W2. W1 again mass of empty calorimeter. What is S2? Specific heat of water. In CGS, its value is just 1. In SI, it varies again. Okay, you know that. T3 is the temperature of the, resultant temperature. T1 is initial temperature. Now we are just checking whether you know each and every term in this so that you can substitute. W3, mass of calorimeter plus water plus solids. You have measured with rough balance. W2 again, mass of calorimeter plus water. T2, temperature of the hot solid. Okay. T3, resultant temperature. So after you substitute everything and simplify, lead specific heat value is 0.02 calories per gram per degree centigrade. So you get it. Students do in our college, they get that value. If you get that value, that means you have done the experiment correct. Otherwise, you have to check yourselves where you have done wrong and again repeat the experiment. So that is how we are determining the specific heat of a solid by the method of, what is the principle? By the method of mixtures. What is the method of mixtures? When no heat is given to the surroundings, heat lost by the hot body is equal to heat gained by the cold body. Okay. So this is called a steam heater. I'm repeating. The purpose of this is only to heat the solid. Okay. 2-layered vessel. And here you will be pouring water. From here the steam comes out. And you keep a thermometer after putting the solid. Once this is ready, you take the, note down the thermometer, keep it out. And then just take it near, switch off the stove. Take it near the calorimeter. After keeping the calorimeter in the wooden box, quickly transfer it. This is there. Quickly raise it. The solid will be transferred. And when you are noting down the temperature, quick, you must, yes, your action should be fast. Yes. Otherwise, what happens? You will not be noting down the resultant temperature accurately. Exactly. Okay? Right. This now, what are the precautions you should observe is just this is one that heat should not go to the surroundings, so that immediately after transferring you know down. And when you are transferring, you must also take care that no water etc. adds to that. Okay, so this is how you are determining the specific heat of a solid by the method of mixtures. If you want, instead of suppose lead shots, iron filings are given, you take iron filings. Okay, iron in the form of small pieces. Okay.
Yes.
Now, why are you not heating it directly? Means for Uniform heating, you are heating the steam
Steam.
heater. Steam heater. Okay. So, thank you.